We're asked in this question to sketch y equals 2 cos x between 0 and 360. So I'm going to draw my axes out. And then my classic cos x graph looks like this. Now 2 cos x is simply a stretch by 2 in the y direction. So I'm asked to indicate the coordinates of any points where the curves meet the axis, and this is how we'll show it. So here we've got 0, 2. And this would be minus 2 along here. This is the 360 point, but I'm not going to label that one. This one here is going to be 90, 0. It's in little blocks of 90. We've got 90, 90, another 90. So this is going to become 270 and 0. And let's just add the x and the y there. But that's a pretty solid sketch for part 1A. Then for B, we're asked to solve this equation. 2 cos x equals 0.8. And what the first thing we'll do actually is get cos x by itself by dividing by 2. So cos x is equal to 0.4. And I'm interested in all the values between 0 and 360. Well, it's going to be very similar to this top graph, but this time I've got cos x. It's actually going to look exactly the same. It's just going to be now it goes through 1 and minus 1. Right, so first things first, let's do inverse cos on 0.4. So we get 66.421. You can say that you're doing inverse cos of 0.4. I've kind of just gone straight to it here. And that would be this value here that I've just found. Because I've gone along from cos back to the angle. There's another answer here, however. So my second answer is going to be, well, look, this distance here is the same as this distance here. This is 360. So to work out the coordinates here, it's going to become 360 minus 66.421. So 293.57. And typically you give these to three sig figs. So x equals 66.4 degrees or 294 degrees. And you can even check your answers. If I've got my answer and I do sine of that, and then I times, sorry, not sine of it, cos of that, sorry. Cos of that, and then I times it by 2, I'm expecting to get 0.8, and I do indeed get exactly that. So brilliant, we can be really happy with that. Secondly, solve this equation, 2 cos x equals sine x. This time we're asked to solve between 180, minus 180 rather, and 180. Presumably inclusive, but that's not going to actually matter. All right, how do we deal with this? We've got a cos x and a sine x. Well, what we need to do is divide through by cos x. So 2 is equal to sine x over cos x. That might seem like it's overcomplicating it, but don't forget this is an identity. It's actually equal to tan x, and we've just turned it into an equation for tan. Tan x looks like the following. Okay, and this is 90 degrees. And then it repeats. So, sorry, I'm just getting my bearings here. This is then, that's 180. It doesn't look perfectly to scale, does it? But this is going to be 270. I'm not interested in that. this is minus 90, and I'm going to get part of it down here as well, where 180 is, minus 180. Okay, so it's important to get this sketch. There are other ways of doing it. I always like the sketch approach because it just tests your understanding of the sketch every single time. We're interested in where it's 2 between minus 180 and 180. So actually, I don't care about this part. It's going to be, I'm going to get one solution from here, and I'm going to get another solution from here. So first things first, let's do inverse tan of 2. $63.434. And with tan, you just simply have to recognize that the period is 180, so we can minus 180, get the second solution. I'm just going to go straight for it. Minus 116.56. So finally, x equals 63.4 degrees or minus 117 degrees. Yeah, do get it written down to more than 3 significant figures, and then just finish by rounding it to 3 sig figs. Brilliant, well done on this.